Good afternoon, everyone. Okay. All right. Well, let's get started with the roll. All right. Jimmy.
Here.
Joanna.
Here.
Ashley.
Here.
Marissa.
I'm here.
Caroline.
Here.
Courtney.
Here.
Jada.
Here.
Autumn.
Here.
Matthew.
Here.
Weston.
Here.
Chan.
Here.
Kelly.
Here.
Porter. Or Seth.
Here.
Trey.
Here.
Kayla.
Here.
Tobias.
Here.
Nathan.
Here.
And Rebecca.
Here.
Awesome. So let's see. Whoops. Wait. So was anyone absent? No. All right. Very good. So anybody have a joke for me today?
What do you call a bear with no teeth?
What do you call a bear with no teeth? Bear gum. I don't know.
A gummy bear.
A gummy bear. Oh, it's close. Dang it. That's pretty good. What do you call a blind buck? I have no idea.
Hey, Mr. Strong, I have one. Well, it's not really a joke, but it's still pretty cool.
Okay, let's hear it.
If you write down the word bed and you look at it closely, it looks like a bed.
Yeah, that's true. That is very true. So are there any other words like that? That look like the word? I can't think of any. Wait. How come we don't? Okay. So I think we're on. Let's see. Hold on just a second. Oh yeah, I was going to tell you my German joke today, but we'll get to that. Okay, so I had asked you to do this problem, I think. And let's try that. Okay, so So it says sketch the interval from 0 to 5. X sub 0 is 2.1. And find delta. All right, so let's see what you remember from yesterday. So let's have so Autumn. Do you remember how to find delta? So Autumn, when you've got it, or if you get stuck or you need a refresher, let me know.
I forgot.
Okay. So what you do, you draw the interval from 0 to 5. Okay? And then x sub 0 is 2.1. That's like your target. Okay? So then what you do is, so if that's your target, then what you do is you measure the distance. And you say, okay, from 0 to 2.1 is 2.1. From 2.1 to 5 is 2.9. So the smaller of those two is your delta. So delta is going to be 2.1. Okay? Now, the other question that I might ask from this is, what's the range of acceptable values? And so then from your target, your 2.1, then you would add and subtract delta. So then it would be from 0 to 4.2. So that's your range of acceptable values is from 0 to 4.2. But, I mean, it just asks you to find delta, which is 2.1. Okay? All right, any questions on that? Okay. All right, so how does this relate to limits? Well, the idea is that when we're calculating a limit, we're just plugging in values that approach 2. Okay, theoretically, we're not even interested in what happens at 2. Now, I know that's not how we do it, but the idea is that x is approach 2. And so if you put in like 1.9, then this will approach 6.9. And if you plug in 1.99, then this will approach 6.99. And so the answer is the limit is going to be 7, because we can get as close to that as we want, because we can get as close to 2 as we want. So 2 is like our target, our x sub 0, or our, okay, so we can get as close as we want. All right, so did we talk about Zeno's paradox? Did I talk about that in here? Ever? No? Okay. So has anyone heard of Zeno's paradox? Okay, so Zeno was a Greek mathematician and philosopher. And so what he said was that imagine you've got a bow and arrow and you're shooting at a target. Okay? And so the idea is that at some point your arrow would have to go halfway to the target. And then at some point it'd have to go halfway again. And then halfway again. And halfway again. And so on and so forth, until reasonably you could say that it has to pass through an infinite number of spaces, because you could keep halving the distance. And so then the paradox is that if it has to go through an infinite number of spaces, then it could not reach the target. But the paradox is that it does reach the target. So it's a paradox. But the idea behind Zeno's paradox is that whatever distance, you can always cut it in half. You can always get closer. You can always, and so the idea of a limit is you can always get as close to 2 as you want, okay, to form the limit. Okay, so to show that the limit of a function as x approaches some number, x sub 0, or I've noticed that in this new edition of the book, they actually use the letter C, but it doesn't matter. X approaches some number. And to show that the limit is equal to some number L, we need to show that the gap between f of x and L can be made as small as we choose if x is kept close to x sub 0. So again, the idea is that we can get as close to the limit as we want by selecting the x value to be as close as we want. Okay. So here, let's say the limit here is 7. So how far off we can be from the limit, we call that epsilon. Okay, that's the little funky looking e, is the Greek epsilon. Okay, and so if we want to be within that range from 5 to 9 in our target, then we need to pick our delta to be between 3 and 5. So, and if we want to narrow this, then we have to narrow this. Okay? It's kind of like let's say that you were an expert in shooting free throws. Okay? So here's the basket. Let's see, I don't know if I can draw a basket, but okay. That's a horrible basket, but whatever. Okay. So that's a basket, and you're out here and you're shooting free throws. Okay. And so you're at the free throw line, and you're really good. You're really good at making those free throws go. But the problem is that that's the only shot that you practice all the time. Okay? So if you go off that target very much, if you go off your spot on the free throw line, then you're going to miss. Okay? So it's like delta is how far off you can be from your spot in order to still make the basket, to still be within the epsilon. Okay? All right. Okay. So, how close to our target, x sub 0 equals 4, does x have to be so that the function f of x equals 2x minus 1 differs from 7 by less than 2 units? Okay, so the way we set this up is we say the absolute value of the function minus 7 differs from 7 by less than 2 units. So the absolute value of f of x minus 7 is less than 2. All right, so let's see, the function is 2x minus 1. So here I just replaced f of x with 2x minus 1. So then if I solve that, I get 2x minus 8. And then to solve an absolute value inequality, just in case you forgot, if you have the absolute value of x is less than a, then you write that as a compound inequality. Negative a is less than x is less than a. So the stuff that's in the box, you might want to put that in your notes if you forgot how to solve absolute value inequalities. because it becomes an interval on your number line, which is exactly what we want. Okay? So to solve the absolute value of 2x minus 8 is less than 2, then we rewrite it as a compound inequality. Negative 2 is less than, and we drop the absolute value, 2x minus 8 is less than 2. And so now when we solve it, we want to get x by itself in the middle. So we add 8 and then divide everything by 2. And so we get 3 is less than x is less than 5. So remember, our target x of 0 was 4. So that means our delta is 1. Because our interval is from 3 to 5, and the distance from 4 to 3 is 1, from 4 to 5 is 1. It doesn't have to happen that way. If they're different, like the other example, you take the smallest amount. But in here, the delta has to be 1. So when this is saying how close does x have to be, that they're asking us find the delta. Okay? Find the delta. All right? Any questions? Okay. All right, so this says, how close to x of 0 equals 4 does x have to be so that y equals 2x minus 2 differs from 6 by less than 2 units? Okay, so this is your f of x, this is your L. Okay. All right, so does everyone have the guided notes? You have this problem written down? Okay, so I want you to do this, but I'm going to go back to the example so you can kind of see how I set up the example. And then I want you to try to see if you can set this one up and solve it. All right, so Joanna, when you've got it, or if you get stuck, let me know.
One.
Okay. So we get y minus 6, absolute value is less than 2. So in place of y, you plug in 2x minus 2. So that becomes the absolute value of 2x minus 8 is less than 2. So negative 2 is less than 2x minus 8 is less than 2. Add 8. Divide by 2. And you get x is between 3 and 5. So since our target is 4, then our delta is 1. Okay, great job. Any questions? Okay. All right. So there's an analogy to this, what we call the scholar versus the skeptic. And so the skeptic says that, okay, so let's say we don't allow you to put in x sub 0 exactly. And so the skeptic says, if you can't put in x sub 0 exactly, then you'll never hit the limit exactly. And so then the scholar says, well, what's your definition of hitting the target? What's your definition of hitting the limit? How far off can we be? A tenth? A hundredth? A millionth? See, however close you tell me I have to be, I can be. I can get a delta so that I can be within any specification you demand, any tolerance level that you have. I can do that. And the skeptic says, well, no, but you can't hit it exactly. And then the scholar says, look, I can get as close as you need me to be. Okay? And so then the debate continues. All right. So one way to think about the definition of a limit is to suppose we are machining a generator shaft to a close measurement. We may try for a diameter, L, but since nothing is perfect, we must be satisfied with a diameter, f of x, somewhere between L plus or minus epsilon. So that's how off we can be. The delta is the measure of how accurate our control setting for x, the units must be, to guarantee this degree of accuracy in the diameter of the shaft. Note that as the tolerance for error, epsilon, becomes stricter, we have to adjust delta. Okay, so how much error we allow, that's the tolerance. Okay, now one of the things that's been probably the country that's been maybe the most famous for their engineering is Germany. Okay, German engineering has always been kind of the standard. But yet it was sort of their, ironically, the word tolerance, their intolerance or their lack of tolerance for error that in some ways helped contribute to their losing World War II. Does anybody know how? What does this have to do with World War II? Anyone have any idea?
Was it to help with when they were flying a plane and they were targeting for bombs dropping to get near wherever they were going for?
Okay, so with German engineering, their planes would actually fly faster farther. They could drop bombs more accurately. Their guns would shoot more accurately. Their guns would shoot farther. Their tanks would shoot better. All right? So how could that ever be a bad thing? Because their machining, their parts, everything was just, they had very small tolerance for error. And so when they produced a gun, it would work better than an American gun. So how could that be bad?
It's extremely expensive and difficult to manufacture something like that.
Yes, everything you said is perfect. So a German gun, there would versus like a Russian gun in World War II would cost 4 times more. Okay, and then you've talked about manufacturing the parts. See, the German guns if there was a part that broke down, a soldier in the field couldn't just replace it. Couldn't just get a part from another gun or whatever. It didn't work. I mean, they had to have it machined so perfectly that in the field, they couldn't, like if an American tank broke down, they could just get, some baling wire and figure out how to keep it going. But a German tank couldn't do that, or a German gun or whatever. And so when the Allies figured this out, that instead of if they were going to lose a bunch of pilots on a bombing run, instead of bombing a tank plant or a factory where they were producing weapons, what might be a better target?
Maybe just the weapons themselves.
Well, or just the parts, the replacement parts. Because they could take out, if there was a machine if there was a factory that produced spare parts, they could wipe out, basically make ineffective a whole, tons of tanks and weapons and so on, just by bombing the parts. I remember that as a kid, I watched a show where they talked about bombing a spare parts factory, and I was like, why? Why would they even care? Well, that's why. Is because the German, it was very difficult to make field repairs. They had to have original parts, to make their machines go. Okay, and so in a lot of ways that helped contribute to their losing the war. Because they had difficulty, and as was mentioned, the cost is that they wanted it to work perfectly, and then they paid for it. So anyway, this is kind of another one: German versus Russian, the cost, and so on. Anyway, it's the same idea. All right. Now, so I had a German exchange student, and I told this joke to him, and he thought it was funny. So anyway, so how many Germans does it take to change a light bulb?
9.
See, that's the second best answer. That's the second best answer. So points for that. All right. Anybody want to guess the best answer for how many Germans does it take to change a light bulb? The answer is none, because they'd rather not see. Get it? All right. Well, okay. Let's keep going on here. So when we set up these limits and we're trying to do this delta epsilon thing, okay, then this part right here that I've highlighted, this is going to be how we set it up. And we'll either say, so we'll say 0 is less than x minus the target, is less than delta implies that the f of x minus the limit is less than epsilon. And so in different problems, we'll be given different parts of this. And so we'll have to use this. Okay? Let's see. Okay. All right. So, all right. So to show that the limit as x approaches 1 of 5x minus 3 equals 2, using the delta epsilon, the definition. Okay. So what we're going to do is say 0 is less than x minus, and so it's whatever x is approaching goes here, is less than delta, implies, or then, the absolute value of the function, so 5x minus 3 goes here, minus the limit goes here, is less than epsilon. And so what we're going to try to do here is find delta. Okay? Or have delta and epsilon related somehow. All right, so if we take this and simplify it, then we get 5x minus 5, the absolute value is less than epsilon. Now, you might not know this, but you can actually factor out of an absolute value. So if you factor out of 5, and then divide each side by 5, then we get the absolute value of x minus 1 is less than epsilon divided by 5. Well, up here, we have the absolute value of x minus 1 is less than delta. So what does that mean? That means that delta, we can pick delta to be epsilon divided by 5. Exactly. Okay? And so what we've just proven is that delta exists. So again, going back to the scholar versus the skeptic, you tell me how close you want epsilon to be, and then I divide that by 5, and that's how close delta needs to be. Okay? And so that's kind of how those are related. Okay? So the thing that's tough about this is that the directions, when it says test the definition or show this, it's not really clear what it is that you do. Okay? And so what I'm saying is if you use those two inequalities that I had you write down, and you write a relationship between delta and epsilon, you try to find that, that's what you do. You try to show that it's possible. Okay? So let's look at this one. So prove that the limit as x approaches 3 of 3x minus 7 equals 2. All right, so all I want you to do is to set it up using those two inequalities. So just write the two inequalities, okay? We're not going to solve them. I just want to make sure that you can plug everything in correctly. Okay, so let's see if you've got that first step. So, whoops. So you write, so, and again, here the order, I would probably start over here in the blue. So 0 is less than the absolute value of x minus 3. So the 3 goes here, is less than delta. So that's the first one. So that implies that the function f of x, So 3x minus 7 minus the limit 2 is less than epsilon. Okay. All right, so any questions so far? All right. Okay, I'm gonna have to close this out. So see if you can find that, solve that relationship between delta and epsilon. Okay, so anyone, can anyone tell me what do I do next here? So what's the process? What is it I'm trying to do?
Pick me. So you make it 3x, and then you add the -7, -2 to get -9. Then you factor out the 3, so you get x minus 9, and then you divide epsilon by 3, so then you get x minus 3 is epsilon divided by 3, and then you say, oh look, delta equals epsilon divided by 3.
Yep, that's it. Well, I really like the oh look part. That's great. That's perfect. Okay, excellent. All right. Any questions on that? So here, so you might have a question that says find delta such that this happens. So in this case, having delta be epsilon divided by 3 is okay. It's not always going to be a number like we've had, like delta is 1 or whatever. Okay. All right. Okay, so for a constant function, since the f of x is equal to the L, then when you do that f of x minus L, since these are the same, that absolute value is going to be 0. Okay. Now that might seem weird, but so that basically means that whatever delta you pick, you're going to be on that constant function. Okay. See, so, I mean, here, if this is the identity, okay, so in this case, whatever this distance is going to be the same up here. Okay, so your delta and your epsilon are going to be equal because this is the identity function. So however, so like if you're off by 1/10 here, then you'll be off by 1/10 here. Okay. Let's see. But see, for a constant, wait, why is this? This is just a repeat. So for a constant function, if you're off by whatever, it's not going to matter because the y value that you're going to hit is going to be the same no matter what. Okay, so your epsilon here is actually 0. Okay, your epsilon is 0. Okay. All right. So here, so if we want to find epsilon here, see that the function is 5, the limit is 5. So when you do your subtraction, see the absolute value of 0 is 0. So you get 0 is less than epsilon. So basically it's, and here you get 0 is less than delta. And so whatever epsilon is, you pick, that could be delta too, or whatever delta pick could be epsilon on this one too. All right. Okay, so to find algebraically a delta, okay, you use this these inequalities. Okay, so we wrote those down already. And so then you solve the inequality with the function, and then you find a delta that will work, that will match. So it's like, oh look, just kind of like what you're saying. Now, there are a couple of little tricks that I want to show you with the algebra here, okay? In case it's not obvious what to do, or it doesn't look like it matches, I can show you a couple of things where you can find delta, okay? But usually it'll work out. And delta has to be greater than 0. Well, I guess delta could be 0. Okay? Anybody need more time on that? Okay. All right. So, whoops. Okay, so this says, for the limit as x approaches 5 of this radical equals 2, find a delta greater than 0 that works for epsilon equals 1. So, in other words, find a delta greater than 0 so that 0 is less than x minus, okay, the target is 5, is less than delta, implies that the function minus the limit is less than, okay, now this one, we're actually given the epsilon. The epsilon is 1, so we can plug that in. So we plug in the epsilon there, okay? So basically this is saying that, look, if epsilon is 1, find a delta that will work, okay? So that's kind of another way to say it. All right, so we set up our inequalities. So 0 is less than x minus the target, 5, is less than delta, implies that the function minus the limit is less than epsilon. But this time we're told epsilon is 1. All right, so now let's go ahead and solve this. Okay, there's really nothing to combine in here because we have a radical minus 2. So to solve our absolute value inequality, we have -1 is less than the radical minus 2 is less than 1. Okay, the problem is usually in like college algebra, you don't solve this ever. You don't solve one of these. Okay, so what steps would you take to get x by itself here? Would you guess? Again, I'm not assuming you've ever solved that before, but let's just, you're smart people. How would you get x by itself here in the middle?
Add 2 to both sides.
Okay, so add 2 to all 3 parts. All right, now what?
Square it, everything?
Yes, you square everything. Now, why is it that you don't have to reverse the inequality? Because sometimes when you multiply, you have to reverse the inequality. Why don't you have to do that here?
Nothing is negative.
Yeah, because see, this is between 1 and 3. So it has to be positive. So when we square it, we're not changing anything. So when we square everything, I'm going to get 1 is less than, okay, then this will come out of the radical, is less than 9, as we square the 3, and then finally add 1. Okay? So now this is my interval. My target is 5. So now it goes back to practice 0 that we did. What's the delta?
3.
3. Very good. See, because this distance is 3, this distance is 5, so you take the smallest one. That's your delta. So when we solve this, we got the whole interval, but then you have to look at what is the target. See, what's x approaching? And so since x is approaching 5, that's your x of 0. That's your target. And so then that helps us find the delta. So we're really going to accept anything between 2 and 8, not 2 to 10. All right? So let's try the next practice problem. Oops. Whoops. Okay, so again on this one I've given you 1 as your delta, as your epsilon, excuse me. All right, Kayla, when you've got it.
Can you go back to the example, please?
Sure. Oh, you got less than a minute. And let me see if I can help you out, because this is actually the last problem for today, because we'll be done. Is see when you solve this, you get 4 is less than x is less than 6, and so your delta is going to be 1. Okay, so anyway, we're done with this, but if you have more questions on Monday, we can go over questions from the practice problems or whatever. Okay,